pH chemical sensor. What does the term pH means? The term pH is derived from P, the mathematical term or symbol for negative logarithm, and H, the chemical symbol for hydrogen. This is what test array of multiple pH units look like. The quantitative information provided by the pH value expresses the degree of the activity of an acid or base in terms of hydrogen ion activity. The pH value of a substance is directly related to the ratio of the hydrogen ion H+ and the hydroxyl ion OH- concentrations. If the H+ concentration is greater than OH-, the material is acidic. The pH value is less than 7. If the OH concentration is greater than H+, the material is basic, with the pH value greater than 7. If equal amounts of H+ and OH- ions are present, the material is neutral with a pH of 7. pH chemical sensor. Acids and bases have free hydrogen and hydroxyl ions, respectively. The relationship between hydrogen ions and hydroxyl ion in a given solution is constant for a given set of conditions. Either one can be determined by knowing the other. This is what pH chemical sensors look like. A pH meter is an instrument used to measure acidity or alkalinity of a solution, also known as pH. pH is the unit of measure that describes the degree of acidity or alkalinity. It measured on a scale of 0 to 14. pH measurement. A rough indication of pH can be obtained using pH papers or indicators, which change color as the pH level varies. These indicators have limitation on their accuracy and can be difficult to interpret correctly in colored or murky samples. More accurate pH measurements are obtained with a pH meter. A pH measurement system consists of 3 parts: the pH measuring electrode, a reference electrode, and a high input impedance meter. As you can see in this figure, on the left side we have the positive measurement electrode, and for the negative is the reference electrode. pH measuring electrode. The pH electrode can be bought as a battery with a voltage that varies with the pH of the measured solution. The pH measuring electrode is a hydrogen ion sensitive glass bulb with a millivolt output that varies with the changes in the relative hydrogen ion concentration inside and outside of the bulb. In this figure, we have KCl solution filling hole, AG or AgCl reference electrode, ceramic frit junction, and pH sensing bulb. Reference electrode. The reference electrode output does not vary with the activity of the hydrogen ion. The pH electrode has very high internal resistance, making the voltage change with the pH difficult to measure. In the figure, we have AG or AgCl internal wire, AgCl or KCl fill solution, and liquid junction. The reference cell maintains a stable potential regardless of the process pH or changes in the activity of other ion in solution. The liquid junction completes the electrical circuit between the pH measuring electrode and the reference cell via process solution. High input impedance meter. The input impedance of the pH meter and leakage resistance are therefore important factors. The pH meter is basically a high impedance amplifier that accurately measures the minute electrode voltages and display the result directly in pH units on either an analog or digital display. In some cases, voltage can also be read for special applications or for use with ion selective or oxidation reduction potential or RP electrodes. pH electrodes. pH electrode technology has not changed much in the past 50 to 60 years. With all the technological advancements of the last 30 to 40 years, pH electrode manufacturing remains an art. The special glass body of the electrode is blown to its configuration by glass blowers. Not a terribly advanced nor high-tech process, but a very critical and important step in the electrode manufacturing. In fact, the thickness of the glass determines its resistance and affects its output. The figure given is the glass electrode errors in pH units. Temperature compensation. Temperature compensation is contained with the instrument because pH electrodes and measurement are temperature sensitive. The temperature compensation may be either manual or automatic. Manual and automatic temperature compensation. With manual compensation, a separate temperature measurement is required, and the pH meter manual compensation control can be set with approximate temperature value. With automatic temperature compensation or ATC, the signal from a separate temperature probe is fed into a pH meter so that it can accurately determine pH value of the sample at that temperature. Buffer solution. Buffers are solutions that have constant pH values and the ability to resist changes in that pH level. They are used to calibrate the pH measurement system, electrode, and meter. There can be small differences between the output of one electrode and another, as well as changes in the output of electrode over time. Therefore, the system must be periodically calibrated. They are used to calibrate the pH measurement. Buffers are available with a wide range of pH values as they come both Prexim liquid form or as convenient dry powder capsule. A buffer solution is a solution that changes pH only slightly when small amount of a strong acid or a strong base are added. A buffer contains significant concentration of both a weak acid and its conjugate base, or a weak base and its conjugate acid. Thank you.